Hello, this is Michael Sulak, and in this video we're going to work through three examples of exponential equations. These are all exponential equations because the variable we are trying to solve for is in the exponent. So let's get started with number one. Here we have 5 to the x minus 8 power equals 1. There's a few ways I can solve this, but because I have my variable in the exponent, every way that I solve it is going to involve the log function. And you have two methods you can choose from. The first one is the rewrite method, and the second one is take the log of both sides. And they'll both end up with the right answer, but they work quite differently. Let's try the rewrite method. The rewrite method is going to involve taking our exponential and we're going to rewrite it as a log. As a reminder, log functions, the format of them is the log with some number here, which is going to be the base. And then we have our input to the log function, and then that equals some result. The base of the exponential is the base of the log function, which means we're going to have log base 5. The exponent in the exponential is the result of the log function. A log function always gives you an exponent. Whatever our exponent is, that's going to be the result of our log function. And then the number 1 here becomes the input for the log function. When we take a base to a power and we get an answer, that answer is always the input to our log function. So when we take this exponential and we rewrite it, we get the log base 5 of 1 equals x minus 8. And at this point, we're very close to having solved for x. We're just going to add 8 to both sides. At this point, we've solved for x. If you want to figure out what the decimal equivalent is, you can use your calculator to do log base 5 of 1. Some calculators have a log base button. If you ever need to evaluate a log with some base that's not 10 or e, the change of base formula just ends up being a ratio of logs with the higher number inside of a log function on the top of a fraction and the base inside of a log function on the bottom of the fraction. And you can use whatever base you want. This is true for any base. I'm just going to use base 10 because that's one of the easier bases to calculate logs. So it turns out that this ratio of logs here is just equal to 0. And so that means x is 0 plus 8, which means that x equals 8. So the other way we could have solved this equation is taking the log of both sides. The easiest way to do that is notice that the base of our exponential is the number 5. And so we're going to take the log base 5 of both sides. And I'm allowed to do this just like I'm allowed to add 12 to both sides. I can keep an equation balanced by doing the same thing to both sides. So if you notice now that we have log base 5 of 5 to the x minus 8, and there's a property of logs that says if you have the log with some base number, let's call it a, and then you have that same number as the base of an exponential inside that log, what happens is that the log function and the exponentiation cancel each other out and you end up with just the exponent. So that's what's going to happen here. We have a base 5 and then we have 5 to the x minus 8. So the only thing that's going to be left on the left side of this equation is this exponent, the x minus 8. And that's why we chose log base 5. We wanted to take advantage of this property. X minus 8 equals log base 5 of 1. This is just a number, so we'll add 8 to both sides, and we've solved for x. And notice that's the same result as we got by rewriting it. We're going to get the same result of x equals 8. So a lot of times with exponential equations, you have a choice of what you want to do. If it's in this form with three pieces, with a base and an exponent with a variable and a result, you can rewrite it as a log function. Or you could take the log of both sides, and if you choose your base to match the base of your exponential, you'll end up with a slightly quicker path to your answer. So let's look at the next problem now. Next exponential equation we're going to solve is e to the negative 2k plus 2 equals 47. K is the variable in this equation. The first thing we're going to look at, is there anything basic we can do to make this look a little bit simpler? And there is. We have a 2 here. And so we're going to just start by subtracting that. And at this point, there's two ways to solve this. You can rewrite it, or you can take the log of both sides. And I'm just going to go ahead and do my favorite way, which is to take the log of both sides. My exponential here is with a base of e. So the log that I'm going to choose is going to be log with that same base. I'm going to choose log base e. We're going to take the natural log of both sides. So now on the left side, I have log base e of e. So on the left side, I'm just going to be left with the exponent. So at this point, something really nice has happened. Our variable that used to be an exponent isn't anymore, and that's going to make our lives a lot easier because we're just trying to solve for k. So we can divide both sides by negative 2, and we're done. And I could check it. If I put this number into the equation for k, I'll get a result that's really, really close to 47. And if I put the exact answer into my equation for k, I'll get exactly 47. So now let's look at the last problem we're going to do. So in this last problem, we have 1/9 to the 2x power times 27 equals 3 to the 5th. So to start off with, let's just get rid of this multiplication. I'm going to use some properties of exponents. 27 is 3 to the 3rd power. I have 5 3's on the top, 3 3's on the bottom, and I'm just going to end up with 3 squared. What I'm going to do is I'm going to write 1/9 as 3 to some number as well. So 1/9 is 1 over 3 squared. That is 3 to the negative 2 power. So what I'm doing is keeping this problem in terms of 3's to some power, and you'll see why I'm doing that in a second. And at this point, notice that in our equation, we have 3's on both sides. And in order for this equation to be true, since these are the same base, the exponents have to equal each other. So if you have the same base, you can just set the exponents equal to one another. All we have to do at this point is just divide by negative 4. And we could simplify a little bit, and we get x equals negative 1/2. That is solving 3 exponential equations. The more you practice, the better you'll get. My name is Michael Sulak, and thank you for watching.